Yo, what's really good, everyone? My name is O'Neil Barnaby, founder and director of the Black Math Academy. I'm here to show you guys what intelligent black society is all about. The other day, on Friday, on my Facebook page, I made a post about an SAT question that I wanted you guys to solve. I said that I would make a video response to show you guys how to go about solving it. So this is me fulfilling my promise to show you guys how to go about solving that question. So let's begin. The question goes, the angles of a triangle are in the ratio 4 to 1 to 1. Then the ratio of the largest side to the perimeter is, and we have to try and figure that out. So the first thing we should do is try to establish the triangle itself. Right? So what do we know? We know that this triangle is isosceles. How do we know that? The ratio dictates that. The 4 to 1 to 1, we notice that the two ones are there, signifying that two angles are the same, and the third angle is 4 times bigger than the other two. That lets us know that this is an isosceles triangle. This angle is the same, and that angle is the same. The angle on top, or the apex, will be the one that's different. Okay? Next thing we'll try to establish are the angles themselves. What values are they? And the way to do that is to use the ratio that they gave us in the very beginning. So since 4 to 1 to 1 is the ratio, ratios are nothing but comparisons to the actual values that they're talking about. So we can use that to figure it out. So the first thing we should do is add those values together. So 4 plus 1 plus 1 is 6. So 6 is going to represent the total number of angles within our triangle. Now, we know the actual total is supposed to be 180. So we're going to use that comparison to figure out the actual value of the three angles in the triangle. So we'll set our ratio up. We use 1 and 6. 1 representing one of the angles in the triangle, and 6 representing the sum of the angles within the triangle. Now we're going to compare that to the actual angles within the triangle. So since we don't know the angle that the 1 corresponds to, just like in mathematics, what do you call something you don't know? You call it x, or whatever variable you want to use. Now 6 is going to represent the total number of angles in a triangle. Now that value we actually do know. All triangles add up to 180 degrees. So we can use that to figure this out. So 1 over 6 is equal to x over 180. And now we have a proportion, and the surefire way to solve proportions is to cross multiply. So we're going to do that. 180 times 1 is 180. 6 times x is 6x. So now our equation says 180 equals 6x. From here, we divide both sides by 6, and we're going to be able to get our answer. That divided by 6, that divided by 6. 6 divided by 6 is 1. 1 times x is x. 180 divided by 6 is 30. So x represents 30 degrees. So the two base angles within our isosceles triangle, they represent the 30 degrees. This is 30, and that's 30. Now the top angle, we don't know, but we can figure it out because we know that the sum of the angles of any triangle is 180. So 30 plus 30 is 60. To get the missing value, we take the sum and subtract it from the values that we already know. So 180 minus 60, which is 120. The top angle is 120 degrees. Now, where do we go from here? Now, the idea is to establish the sides of this triangle because that's what the question is asking for. We want to compare the largest side to the perimeter, so we need to know the sides of this triangle. Well, one trick you can do is to draw what's called a perpendicular bisector, or pretty much just a straight line from the top to the bottom. Right? Perpendicular means 90 degrees, so we just created a 90-degree angle within the triangle. Right there. So again, any triangle adds up to 180 degrees. So within this triangle on the left here, we have a 30-degree angle and a 90-degree angle. 30 plus 90 is 120, which makes this split angle here 60 degrees. And the same goes for the other side as well. This is also 60 degrees. So now we have a 30, 60, 90 triangle. Now that is a special triangle when it comes to geometry because that specific type of triangle, the sides are related to each other. What that means is that if you happen to know one side of the triangle, that means you actually know all three of them because they all have something in common. So, excuse me. So to show you that relationship, 30, 60, 90, those are the values of the angles of that triangle. The relationship is x root 3, and 2x. Those are the values of the three sides of the inner triangle. And the way to remember that is that I put them in order from least to greatest. X is across from the 30, x root 3 is across from the 60, and 2x is across from the 90. So here's 90. Across from that is the 2x. Across from 30 is x. That's the height of the triangle. And across from the 60 is the x root 3. So that goes down here. And those values are also repeated on the other side of the big triangle as well. So this is 2x. This is x root 3. So now we have the sides of the triangle. Even though we don't know the value of x just yet, that's actually, irrelevant because we know the representation of the sides. So that is just as good. So now we can actually solve the problem. So the question is asking the ratio of the largest side to the perimeter is. So we need to compare those two aspects, the largest side and the perimeter. Well, what's the largest side of the triangle? Well, of the big triangle, the largest side is across from the biggest angle. So since 120, the entire thing here was the biggest angle, this side here is the biggest side. Now, right now, it says x root 3 and x root 3. So that means we have to add those two values together to get the sum, which would represent the entire length of that side. So x root 3 plus x root 3 is 2x root 3. So that's the largest side. Now we want the perimeter. Well, perimeter is easy. Perimeter just add up all the sides of a triangle. So we've got 2x plus 2x plus 2x root 3. So we're going to put that in our fraction in the denominator of that fraction. So 2x plus 2x plus 2x root 3. So 4x plus 2x root 3. That becomes the representation of the ratio of the largest side to the perimeter of that fraction. And then from here, we can simplify this fraction by pulling out a common factor from the denominator. So 4x and 2x, those two values have something in common, and that value is 2x. So we're going to pull that factor out, and what's left will be the distributive property. So the top remains the same, 2x root 3. 2x comes out, and what's left is the result of taking the 2x and dividing it by the two terms on the inside. So 4x divided by 2x is 2. And 2x root 3 divided by 2x is just root 3. Because 2x divided by 2x is 1. So it becomes root 3. All right. Now that we have products on the top and the bottom of the fraction, we can now simply reduce. Whatever's the same on the top and the bottom simply cancels out. So 2x over 2x are the same, so they literally just cancel out. And what remains is root 3 over 2 plus root 3. That's a plus. All right. Now, in mathematics, we tend not to have a radical in the denominator of a fraction. It just makes things really complicated. It makes things weird to solve and to simplify. So mathematics tells us that we have to remove that. And the way to do that is to apply what's called the conjugate. Now, the conjugate is just taking the sign that you see here and just flipping it to its opposite. So since we have 2 plus root 3 in our denominator, the conjugate is 2 minus root 3. So the way we're going to remove this radical in the denominator of our fraction is we're going to multiply this fraction by its conjugate, top and bottom. And so I'll do it over here. So root 3 over 2 plus root 3 times 2 minus root 3 over 2 minus root 3. Okay. Now, the reason why we do that is because we're trying to get rid of this radical. That's 1. 2, the fraction that we're multiplying by is basically 1. And anytime you multiply by 1, you're not changing the value of the original fraction at all. But we are going to change the way it looks because we're trying to get rid of the denominator with that radical within it. So it's just a simple matter of multiplying these two fractions. So root 3 times 2 is 2 root 3. Root 3 times root 3 is actually 3 because we're multiplying the same thing, and which means we're squaring it. But since squaring and square rooting are the opposites of each other, they just cancel out as well. So it becomes 2 root 3 minus 3. That's your top or your numerator of your fraction. Now the denominator, because they're two-termed expressions or binomials, and we have 2 of them, this is an example of foiling. So we're going to have to follow the rules of FOIL to be able to multiply these 2 terms. Now it just so happens that these 2 terms happen to have the same values and also have opposite operations. One says plus and one says minus. So that means it's a special case. There's a faster way to go about solving it without having to use FOIL itself. So I'm going to do that pretty quick. 2 times 2, that's 4. Root 3 times root 3, that's 3. And we're simply going to minus in the end. And that's the faster way to go about doing it. I'll explain that later in another video. So now we have 2 root 3 minus 3 over 4 minus 3. 4 minus 3 is 1. That's solvable. So we have 2 root 3 minus 3 over 1. And this cannot be simplified any further. It's as simple as we can get it. And this is the ratio of the largest side to the perimeter of this triangle. It happens to be this. Well, this is an example of intelligent black society. So with that being said, make sure you remember that math is where it's at. Peace.